Wait for 5 minutes. Everything is fine or not? Wait for 5 minutes. Yeah. So in this lecture, we study initial value problem. Okay. In differential equation, something. Then further focusing on existence and uniqueness theorem and its geometrical interpretation. Okay. So this topic is fundamental for understanding when the differential equation has a solution. Okay. And whether that solution is unique. So we begin with the concept of the initial value problem. Okay. So where a differential equation is combined with initial condition, then we explore the existence theorem. Okay. This next part we explore for existence theorem, and which tells something which tells us when at least one solution exists, then followed by the uniqueness theorem, which guarantees whether the solution is single and well defined. So finally interpret this result in geometrically using directional field. So the directional field is nothing but it is just slope fields. To understand how solution curve behave visually, this provides deep insights into the structure of differential equation and helps in both theoretical understanding and practical problem solving. So this lecture is essential for a student uh, for preparing for GET exam, CSIR NET exam, BSc, MSc, Mathematics, Engineering Mathematics, or any other competitive exam. So topic covered, I think introduction to initial value problem, first and second order initial value problem, first order, okay, geometrical interpretation, existence and uniqueness solution, some theorem, and interval of definition versus existence. So hopefully, so initial value problem. Now I'm going to teach you some initial value problem. So what is initial value problem? First thoughts comes in your mind. That is the definition of initial value problem is nothing but on some interval I containing x0. The problem look like this. The problem look like by some independent variable and some independent variable and derivative goes on to up to n minus 1, that is d to the power ny upon dx to the power n. So subject to that is yx0 which is y0, when combined when take its derivative, then also the y1, it's not the it's just a notation for any arbitrary specified real constant. Okay, so these are called as initial value problem. So initial condition for our initial value problem, first of all I am check on YouTube everything going good or some problem, because in this portion in this portion only write, I don't know, I cannot write now, so must be check it. Yeah, everything is fine. So hopefully today I am going to teach you some introduction which is basically based on initial value problem. Initial value problem its and existence of solution. Okay, so in this part, so one take some example here. I'm going to take some example, then explanation. So initial condition here, when I are taking some interval I containing x0, the problem is basically based upon this d to the power n y upon dx to power n. Hopefully, x is our independent variable, y is our dependent variable. Okay, now come to the slide part. Wait a minute for some time. There is some issue. Okay, I am audible now. Wait a minute for. I think I take some time to take your class. Okay. Yes, I think. Okay. So for initial value problem, for some interval I containing x0, okay, uh, it's better to be right, okay, because when I time when the time I create my slides, the whole content are really here and there actually pasted. So hopefully I am going to write this and then I will explain to you. So hopefully you understand this, na? Yeah, okay. So initial value problem is nothing but something like these are the subject to notation, and for some interval I, okay, and x0 the problem. Now it's better to be right here. So in initial value problem, in initial value problem, it is nothing but on taking some interval that is I containing x0. Okay, the problem now, this type of problem solve this, and the format for initial value problem is d to the power n y upon dx to the power n, which is equal to the there is some here y dash up to y n minus 1 times. Okay, it is correct. Now solve for this, and subject for and subject to something initially yx0, which is right in the form of y0, and when you take their derivative it goes on y1 times. Okay, and there so when you uh, take their n times derivative, then you write like this, and minus 1 x0, okay, x0, which is equal to yn minus 1. That is the derivative part. So where these are y1, y2, yn to the power minus n are arbitrary specified real constant. So these are called as initial value problem. Okay, where y1, y2, I think y dash is better to be okay. No problem. Take some more notation here. Y0, y1, y2 goes up to y and minus 1. Okay, are arbitrary constant as arbitrary constant, that is means basically arbitrary real constant. Okay, so it's called initial value problem. Now come to the my first slide. What I'm trying to say you, when you take some yeah, here is the content. So these are the arbitrary specified real constant, that is our is called an initial value problem. So basically it's divided into, there are two type of category. First one is our first order initial value problem, and second is our second order differential order initial value problem. So how to deal with some this concept? So initial condition is nothing but when a value specifies like yx, and for first n minus 1 derivative at single point x0, then you write like this their initial condition like this. Okay, so our next point is deal to you first order initial value problem. So first order differential initial first order initial value problem is what? I'm going to write like this again. Take one more slide. Okay, so first order initial value problem, basically when you take some graph, actually I am showing you in a PPT. So solve for the notation dy by dx, take a two function which is take some two variable x and y. So their first derivative and subject to what? Subject to yx0 which is equal to y0. These are first constant. And next one is our solve for d to y. Then your notation like this: f x, y, and y dash. And subject to right for a different notation, take there is at a form of yx0 which is equal to y0. This is the notation only to change in format of initial value problem. So here is the yx0, what yx0 basically write in format of yn. So hopefully you understand the first order initial value problem. Now come to the graph part. So graph part basically tells about, here is the solution of ODE. This look like the solution of ODE, and here is the notation for x0 and y0, and that is our internal. That is your first order initial value problem. And second, in this figure 1.1, we went to find a solution of the differential equation whose graph not only passes through x0, y0, okay, x0, y0, but passes through so that the slope of the curve at this point is y1. Now come to this figure that is related to second order differential equation. So in figure 2, hopefully you understand this. Okay, so these are the part of second order initial value problem. That is when you take the second derivative portion, it is a first order initial value problem, and this is the second order differential initial value problem. Now x, y, and y dash subject to write like this, represent y x0 in initial value problem, y x0 which is equal to y0, and y dash x0 is equal to y1. So that is their figure like this, and hopefully you see their slope part m is equal to y1, that is passes through one single point, that is x0 and y0. These are the graph like this, I think. Hopefully you understand this graph. Take a one point here and take a one tangent pass through this point, and this point is nothing but x0 comma y0, and that is m, which is equal to yn. Okay, that is slope. That is our. So the term initial condition derives from physical system where the independent variable is time t. Okay, these are the simple points which we will study in this topic. Uh, the term the initial condition derives from the taking a sum y t0 is equal to y0, y t0 is equal to y0, and y dash t0 which is equal to what, which is equal to y1. These are the representation. These are the represent respectively the position and velocity of an object at some beginning or initial time t0. So solving for nth order differential equation problem frequently initialize using a n parameter here family of solution, and given differential equation to find the n specialized constant to that the resulting particular solution of the equation. So also feels that it satisfy the an initial condition. Okay. So now the point is first order initial value problem. Now comes to one example which is related to initial value problem. These are the geometric interpretation already I am show you. That is the in first order initial value problem, seek a solution curve passes through the prescribed point x0 and y0. And in second order initial seek curve that passes through x0 y0 has slope y1, which is equal to written like this y1, m is equal to y1. So physical interpretation, when the independent variable is time t, then y t0 which is equal to y0, that the your initial position, and their first derivative which is equal to y1 represents initial velocity. So these are the solving method, and which is actually solve an nth order initial value problem frequently entitled using an n parameter family for solution to find n specialized constant. So resulting part studies the initial condition. Now come to the one example part, which is really good to look you, and hopefully you understand their graph correct way. So in this first order initial value problem, here you see the one parameter family of curve solution for y dash which is equal to y equal to minus infinity to infinity, and verify that y is equal to c e to the power x. So we specified first here how this parameter family of solution look like. So I think I show you graph. Okay. Actually, this point solution of initial value problem. Yeah, here is the graph. When you take this point 0 comma 3, and here is 1 comma minus 2, how it comes? It comes by taking here the substitution x is equal to 0, y is equal to 3. It gives you 3 is equal to c e to the power 0, which is equal to c. Okay. So thus y is equal to 3 e to the power x is also a solution for this first order initial value problem. And when you take their derivative, which is also equal to y, and y0, their first order is y0 is equal to 3. Okay. So these are the first part, and their graph look like this. Now come to the second part, that is our B part. When you have something equation like this, y is equal to c to the power x, which is one parameter family, and your interval look like this, minus infinity to infinity, then your demand y1 is equal to minus 2 here. So when you put this value in this equation, you got a y dash is equal to y, and y1 is equal to minus 2. And here I show you their graph. Okay. Now come to the next part, that is our one more example which is related to interval of definition. Hopefully you understand this. Now come to the next point, which is our interval of definition of a solution. So take one problem here, okay, and take one problem here. Consider y dash is equal to. Actually, I am going to write this. Then I will explain to you my slide. Okay. Yeah. One more example related to interval of definition of a solution. So the part is interval I of definition of a solution. Yeah. So how to write this? Actually, I am showing the few problem type. So take a one example. So take a one first order differential equation and in question format so that a one parameter one parameter family of solution of the first order differential equation and differential equation is y dash plus 2y square which is equal to 0 and is y equal to y is equal to what? Y is equal to 1 upon x square plus c. Okay. If we impose the initial value condition, now take here. Now how to solve this problem? Okay. So consider the function and their domain like this. I think for this solution, take a substitution. Take a substitution. I think x is equal to 0 and y is equal to minus 1. So the initial condition y 0. Uh, so here the initial condition that is y 0 which is equal to minus 1 and the substitution for our problem that is x is equal to 0 and one more y is equal to minus 1. This into the family into the family of solution given gives what when you put this y to minus 1 put substitute in this then it comes like this minus 1 which is equal to 1 upon c, okay, or c which is equal to write like this minus 1, okay. So thus these are the y is equal to, hopefully you understand this, y is equal to x square minus 1 terms are come. So we now emphasize the following three distinct, okay. So the consider in this function, consider as a function the domain of y is equal to 1 upon x square minus 1 is the set of real number x, okay, for which y is equal to x is defined. So this is the set of all real number except x is equal to minus 1 here. When you put x is equal to minus 1, then it's becomes 0. So put here x is equal to 1, then already it comes 0. So in both cases, the satisfy here x is equal to minus 1 and x is equal to 1. Now I'll show you their graph portion, and its graph look like this. Yeah, here is one part. Okay, I think I cannot put here their graph portion, but really needs this. As a function, their domain is a real number except x is equal to plus minus 1. So as a solution, the differential equation largest interval for definition are minus infinity to minus 1, and second one is minus 1 to 1, and next one is 1 to infinity. So as a solution of initial value problem, y0 is equal to minus 1 must contain x is equal to 0. So interval is our minus 1 to 1. Okay. I'll show you their graph portion. Hopefully, wait for some time. Actually, I cannot paste here. Okay. Yeah. For function, because when you try to draw their graph, it's look like this. Okay. Here the x part, and here is the y coordinate, and now take their some two gap, because the for only we talk about minus 1 and 1. Okay, so here one range for minus 1, and second one is for 1. Now there, now I'm going to draw a graph portion like this. Okay, and here one more graph like this. Okay, and rest part drawing this portion. Their graph look like this type of graph. These are the function which is actually defined for all x is equal to except here minus 1 and 1. Okay. Now these are the only consider as a function. When you considered as a solution of differential equation, okay, and then there something like this. Now there I'll show you in, wait for some time. Yeah, here. Okay. So consider here as a solution. These are the or where you put x is equal to plus minus 1 here, then the value becomes 0. So do not consider, and their graphs look like that one. Actually, I have already told you. So consider as a solution of differential equation. Here the differential equation already given here. Y dash plus 2x square. These are y dash part, which is equal to 0. So the interval I of definition, which is equal to y is equal to 1 upon x square minus 1. Okay. So could be taken to be an interval over the which yx is defined and they are differentiable. So as you can see in the figure portion, there are larger interval on which and the solution are like this: minus infinity to minus 1, and here is minus 1 to 1, and 1 to infinity. Okay, that is the solution for the initial value problem, actually already given here. So Now come to the second order initial value problem, and let's check with one example. And the example look like this. Yeah, here is the one more example, which is basically based upon second order initial value problem. So actually, first I am explain this, then okay. So now come to the slide part. Actually, written portion is very good. Okay, when I write any content, it's gives me some idea about topic. Actually, I know the topic, but hopefully it's show you some good content. So now the second order initial value problem. Okay. So in second order initial value problem, I will show you some example. X is equal to C1 cos 4t plus C2 sin 4t. First is a two parameter family of solution. Okay. And it is a two parameter actually already show you already you see here these are the two parameter family of solution. These are two parameter family of solution, and one more they are the x dash plus 16x which is equal to 0, and your aim to find the initial value solution initial value problem. Find a solution of the initial value problem. Okay. So now the solution part. Actually, write the solution part here. These are problem part. Okay. So first you maybe apply x pi by 2 here. Okay. X 90 which is equal to minus 2. So it gives the family of solution for C1 cos 2 pi plus C2 sine 2 pi, okay, which is equal to minus 2. So since cos 2 pi which is equal to 1 and sine 2 pi which is equal to 0. So we find first that we find that C1 is equal to minus 2. We next apply x prime, okay. Now when you take here the derivative part x pi by 2 which is equal to 1. So that the one parameter family I think put here xt which is equal to minus 2 cos 4t plus c2. Okay. C2 sine 4t. That is that is notation in parametric form. So differentiate this with respect to differentiate and then setting t is equal to pi by 2 here. When you set this, then x prime which is equal to 1, that gives you 8 sine 2 pi plus 4 c2 cos 2 pi which is equal to 1. Okay. So from which we see that here c2 is equal to, it is nothing but 1 by 4. So hence your solution like this. Okay. X is equal to minus 2 cos 4t plus 1 by 4 sine 4t. That is the solution of solution part. Okay. So hopefully, and their graph look like this. Their graph look like this. I think needs eraser here. Yeah. Actually, in pad tab, lot of difficulty I faced to show you something new. So I take a one scale and then draw the, okay, wait a minute. Yeah, free writing is better. So take here one graph. Here is the x portion, here is the y portion, and here my graph look like this because we are drawing in between free from 1 to -1. Okay, so here is 1 and here is -1, and my graph between this, that is look like this, that is the point is 0 comma -1. Okay, so hopefully you understand this. These are the solution defined on interval containing x is equal to 0. So I think the graph portion, hopefully you understand. Okay. My aim is to discuss you some new concept that is based on existence and uniqueness. First of all, wait for 2 minutes because I pick a one call, then I will explain you. Now, the next topic is our initial existence and uniqueness. So, in this problem, that is their general solution, characteristics equation. Okay. First of all, I am showing you their steps part. Same question. So, in this question, first one is write their general solution. Their general solution look like this. The given differential equation is like this now. X double derivative 16x which is equal to 0. They have some characteristics. So their characteristics equation which is r square plus 16 which is equal to 0. And here r is equal to plus minus 4i. Okay. So the general solution is xt which is equal to c1 cos 4t plus c2 sin 4t. You assume this, na? You keep in your mind that is the steps for solving our previous problem. So in step 2, apply first. I think next to erase this. Yeah. Apply first in initial condition here. Okay. So here your initial condition like this, x is equal to pi by 2. Basically pi by 2 which is equal to -1 type. So substitute t is equal to pi by 2 here. So x pi by 2 is nothing but it's look like c1 cos 2 pi plus C2, sorry, here is C1 is missing and here is C2 sine 2 pi. Okay, since cos 2 pi which is equal to 1 and sine 2 pi which is equal to 0. So we get C1 is equal to what? C1 is equal to nothing but it is look like minus 2. So hopefully you understand this now. So the value of cos 2 pi which is equal to 1 and sine 2 pi which is equal to 0. Now in next slide, so we get the this condition, yeah, in this problem is our theorem. Okay, is an initial value problem, and in same problem we discuss about this portion x double derivative plus 16x is equal to 0. So x pi by 2 which is equal to minus 2 and x prime pi by 2 which is equal to 1 and x pi by 2 c1 cos 2 pi c2 sin 2 pi which is equal to c1 the value c1 which is equal to minus 2 xt which is equal to minus 2 cos 4t c2 sin 4t and their derivative first derivative is x 8 sin 4t and 4 c2 cos t. Here the x prime pi by 2 which is equal to 8 sin 2 pi plus 4 c2 cos 2t which is 4 c2 equal to 1 and the value of c2 is equal to 1 by 4. So in this solution c1 is equal to minus 2 and c2 is equal to 1 by 4. Okay. So come to the my slide. Yeah, c1 is equal to minus 1. Okay, yeah, here c1 is equal to what? C1 is equal to actually I calculate now. C1 is equal to minus 2 and C2 is equal to 1 by 4. Hopefully you understand this and apply the second initial condition here. So you get this C2 is equal to 1 by 4. Now the final answer is look like this: x is equal to minus 2 cos 4t plus 1 by 4 sin 4t. Okay, yeah, this is t. Actually my writing is not good on pen tab, so hopefully you understand this. These are the graphical approach to solve this problem. Now come to the next slide, that is important part. And yeah, so this is our problem. Actually, we study here. Now in next part, the portion that is existence and uniqueness fundamental question. So initial value problem and boundary value problem. So initial value problem and boundary value problem, and now the next part is our existence of and of solution. So initial value problem, you already solving the section will consider the other sample problem of the following example. That is a find of solution of f of the differential equation, and their explanation portion already I have told you. Now their notation part already I have told you, and some solution portion. Okay. Now in next portion, we study about existence and uniqueness part. Okay. So in existence and uniqueness part, first of all, need to explain you existence of solution. Okay. So existence of solution, does a solution of the problem exist? Uniqueness, if a solution exists, it is unique. Okay. So in the first order initial value problem dy by dx, which is basically equal to fx comma y, and their notation is yx0 is equal to y0. That is the notation of initial value problem. So existence does the differential equation poses the solution. Do any solution curve passes through x0, y0? And next one is uniqueness, when we can be certain that there is precisely one solution curve passing through x0, y0. Now I'm going to show you some example. Hopefully you understand the all question already I am asked you in this topic. So now come to the next part, that is considered one initial value problem, that is our dy by dx which is equal to x, so I 1 by 2. Take here the condition, initial condition, that is our y0 equal to 0. So in this part, first you satisfy the differential equation, okay? Then when you take here the y equal to 0, then it comes look like y is equal to 1 by 16 x to the power 4, okay? Hopefully the main example of this problem is here and there. Maybe I need the book part to explain you, okay? Wait for some minute. Yeah. So the verification for this initial value problem, wait for some minute. Yeah. Okay. So question arises here. The existence part is basically based upon existence and uniqueness portion. Hopefully, I will show you in existence of a unique solution, their definition part. Okay. So here is some theorem related to existence and uniqueness. An example, here is some three important sets. So local uniqueness, initial value problem, first order, second order, summary, their key points are already. So in this uniqueness and existence and uniqueness portion, I will show you some theorem based on it. So here let R be the rectangular region in xy plane defined by ax, x is from a to b and y is from c to d, okay? That's contain the point x0 and y0 in this in its interior part. So if function is our f is to f in bracket x comma y, and their derivative df upon dy are continuous on R, then there exists some interval I0 which is equal to x0 minus x h, and second one is x0 plus h, okay? So here the h is greater than 0, so contained in a comma 0, that is our, and a unique function yx, so defined I0, but the solution of initial value problem. So here the function is the derivative dy upon dx which is equal to fx comma y, and their initial value problem initial condition is yx0 is equal to y0. So in this figure, there is some rectangular region actually show you, and their graph are going look like this. Okay, these are the x0, y0 portion. So actually, I am going to write their definition, and in this style of theorem, actually these are the existence of unique solution. Okay, so these are the already example part, and interval of existence and uniqueness in next part. So actually I am show you existence and uniqueness part, okay? So an initial value problem can have several solution. So by an example I will show you. In this example, Also, you here the consider one initial value problem dy upon dx which is equal to xy power 1 by 2 and their condition is y0 is equal to 0. So here the both functions satisfy the differential equation and y0 is equal to 0 here put take their derivative part xy 1 by 2. Here is one more condition that is each function for the y is equal to 1 by 16 x to the power 4. So their verification, first you go with their derivative portion. Okay, so dy by dx is nothing but take here some more part. I think the whole part are missing here something. Okay, so needs to correct this. Yeah. So in a revised portion, actually I am show you. Okay. Yeah, here is their graph portion. Two solution of the same initial value problem. Okay, I think their graph. So here the equation is y is equal to 1.16 x to the power 4 and second condition is y is equal to 0. The origin is 0 comma 0 and graph look like this. Okay. So by theorem, I will teach you the existence of a unique solution. So in this theorem, actually we study about the existence of a unique solution. Okay. So now in next portion, there is some example, a revised example. Okay. So I think this portion is dy upon dx which is equal to x y to the power 1 by 2. Their function part is fx comma y which is equal to xy 1 by 2. Now their derivative portion is nothing but x upon 2y to the power 1 by 2. So this function how behaves like this. So these functions are continuous in upper half plane where y is greater than 0 and conclusion for the theorem given theorem. I think already the solution is behaves like a unique type solution. So through any point x comma x0 comma y0 with y0 is greater than 0, there exists some interval centered at x0 on which the initial value problem has a unique solution. So in example, even without a solving, we know that dy upon dx which is equal to x to the power 1 by 2 and yt is equal to 1. So these are the unique solution on some interval centered at x is equal to 2. Now one more application based on it. So for y derivative, what y dash is equal to y. So their function, both function are continuous to the center xy plane. Okay. So theorem granted there are no other solution y derivative which is equal to y and y0 is equal to 3 and y dash is equal to y, y1 is equal to minus 2 other than y is equal to 3 e to the power x and y is equal to minus 2 e to the power x minus 1 respectively. So the interval on which each solution is defined is minus infinity to infinity. I think you understand my point. Okay. One more book need to explain you. I think needs to yeah. Hopefully you understand this now. I cannot see my YouTube chat or everything. Only I am going to teach you the exact differential equation. The exact differential equation is looking like what types of. Okay. So you know the exact differential equation look like. Only in this time only I am teach you existence and uniqueness part. So I have one more problem, actually based on uniqueness of solution of any differential equation. Okay. Now I'm going to teach you, take one more example. Hopefully you better to understand this and better for you. Okay. So initial value problem, let's just take one more example here. First of all, the function f must satisfy the differential equation. Okay, that is, the function f must be such that look like when you take some derivative, look like this: dy upon dx, which is equal to 2x. Okay, so here the condition is x is equal to 1, and solution f has the value, yeah, 4. Okay. So in first part, first let us be certain that we thoroughly understand this problem. So we see a real function f which fulfill the two following requirement. So first requirement is, if function satisfy the differential equation, satisfy differential equation, okay, f must satisfy the differential equation, that is, the function f must be such that their derivative is f dash x, which is equal to 2x. Okay, for any real x in real interval I. Second part, the function must have the value 4 at x is equal to 4. Okay, that is, the function f must be such that f1, which is equal to 4. Now, their notation, I think these are the stated problem may be expressed in following somewhat observation, abbreviative notation. So their notation is dy upon dx, which is equal to 2x, and y1 is equal to 4. Here is y1. Okay. So in this notation, and their solution is look like, their solution is look like this. Take a here, the solution look like this: y is equal to x square plus c. Okay, so c is nothing but it is the arbitrary constant. Okay, when you take here the derivative part, then it comes to, fully you understand this. So maybe you take here the some problem like this: first you must satisfy the differential equation, then you further the go for the further calculation. Okay, one more example, actually I show you. Take here the second derivative, second order differential equation. So initial value problem. Here is the d2y upon dx square plus y is equal to 0. And condition is y1 is equal to 3 and y dash 1 is equal to minus 4. So in this problem, menu consist in finding a solution of differential equation. Then you go for the d2y upon dx square plus y is equal to 0, which assume that the value, uh, which assume that the value 3 at x is equal to 1 here. So first derivative assume that the value is equal to minus 4 at x is equal to 1. Both these conditions relate to one x value, namely x is equal to 1. Thus, these are the initial value problem. Okay, and solution is must unique. Now come to the one more definition part that is related to the first order differential equation. Actually, I have already told you, which have some definition that for the first order differential equation, which is actually related to your initial value problem. So no need to tell you the definition part. I go with one more solve the initial value problem. So actually, I'll give you some homework portion here. Solve the IVP only dy upon dx, which is equal to minus x upon y. Okay, and condition is y3 is equal to 4 here. First problem, and second problem is related to existence of solution. Okay, basic existence and uniqueness theorem. So yeah, here is the one more problem. Okay, so question is dy upon dx, which is equal to x square plus y square, and their condition is yn is equal to 3. Now next problem is one more question, dy upon dx, which is equal to y upon under root x, and their condition is y1 is equal to 2. Next question is dy upon dx is equal to y upon under root x, and their condition is y0 is equal to 2. So here first you go with this type of calculation, fx comma y, which is equal to y upon x to the power 1 by 2 for this. Okay, and what, and derivative of x comma y upon dy, which is equal to 1 upon x1 by 2, like this. Okay, so one more question for you. Okay, so there is one more question, so that y equal to 4e to the power 2x plus 2e to the power minus 3x, okay, is a solution of the initial value problem. Now in this portion, d2y upon dx square plus dy upon dx minus 6y is equal to 0, y0 is equal to 6, y dash 0 is equal to 2. So okay, so these are the basic question already I am show you, and do it in your homework part. So I hopefully you understand today lecture. Yeah. So thanks for watching this video. Meet you in our next class. Okay. Okay. So thanks for watching this video.